Okay, so welcome everyone. This is the part 7 of a binary tree series, and the question we're going to solve now is question number 637, average of a levels in a binary tree. And this is also a type of a question in which we use a binary tree, level order traversal method to solve this question, because when we iterate each level like 3, 9, 20 and 15, 7, the three are the levels of the binary tree, and when we iterate the three levels, then we got the average of the both the levels. Like in the first case we see a 3, so the average of 3, there is only one node present, so we divide the 3 by 1 and we got the value 3.0000 in the output. And after that 9 and 20, so we add the 9 plus 20 and divide by 2. It means average is basically a total number divided by the how many numbers are present in the nodes. And in the third case we see the 15 and 7, and they also are two numbers, so we divide also by 2 and we got the value 11, because 15 plus 7 22 and 22 by 2 is 11. And here we see the average of value of the nodes on the 0 is 3 and level 1 is 14.5, as well as on 2 is 11. And there is also a 0.00. It means it says that you can use a double data type to just store the output in this question. And okay, so let me see the example 2 as well, as so that we conclude all the cases. And in the example 2 we see 3, 9, 20, 15, 7. Here we also divide 3 by 1 and 9 plus 20 by 2 and 15 plus 7 by 2, so that we got the output 3, 14.5 and 11. See, and here we write the code. I hope you understand the question. If you didn't got, then please see the question twice and then see the code. Okay, so here we make a vector result, which is a type of a double, so that this can store the point values like 0.00 and at all many things. Okay, so we make a result and we apply the base condition. Here we say if our roots value is equals to a null pointer, then we say return result. Okay, this is the base question of the problem. I write here the base part. Okay, after that we just use a binary tree traversal method so that we can iterate the each level. And how we can iterate, I can explain you further in my previous videos. So we apply queue and tree node, okay, then make it name queue and we push the value of in the queue. Okay, and we check while applying a while loop is if our queue dot empty. Okay, so here we check. Firstly we initialize the size variable, which is of a data type int, equals to queue dot size. Okay, sorry, it's a queue dot size, and apply a semicolon after that. And then we to calculate sum, so that we can divide it by the size, then we got the average value now. So to calculate sum we need to initialize a variable which is name of sum. So we use the data type double for the sum and equals to, let's suppose, 0 in the initial case. After that we apply a for loop for int I equals to 0, I up to size and I plus plus. Okay, this can iterate in the each node. After that we just need to do apply a current, okay, so we need to do here a tree node name current, which is equals to the queue dot friend. This is exactly as the same code which we use in the binary level order traversal. So this is the one of the most important case in the binary trees. If you didn't got the a concept of a binary level order traversal, then I can't say that you can solve all the problem related to this question and many of the problem in the Leetcode, because they are one of the most powerful concept which we use in the level order traversal by the help of the queue. and after that queue front, and then we apply queue pop. Why we apply a queue pop? It's just because if we iterate each element and we store in the queue, then we apply the queue pop just because to store the next values. If we didn't got the next values, then what is the point? Okay, to enter the new values we just need to pop the element which is present in the queue, so that the new elements enter and we count them. Okay, and after queue pop we just do the sum plus equals to current value which is stored in our queue. Okay, and okay, so we here write if our current left is present in our node, means not null, equals to null pointer. Okay, so here we push the value in our queue which is current dot left. Okay, and again the same case we write for the right case. Okay, if our current dot right is present in our tree, means it's not equal to the null pointer, then we push current right in the queue. Okay, after all that we just need to write one more condition. Here we write the result dot push back so what I said earlier, that we need to, to calculate the average we need to calculate a sum, and we need to divide it by the size. So in the first case we store the value 3, so we need to divide it by the 1, and the size of the queue which is in which we store the value of 3 is a 1, so we divide 3 by 1, and after that we pop the 3 element and then store the value 9 and 20 in the first case, you see. And after storing the 9 and 20 we need to divide it by the size. Firstly we can calculate the sum like 9 plus 20, and then we divide it by the size. So what is the size? So here the 1 and 2, only 2 elements present, so we need to divide it by the size. So by this concept we just need to push back sum divided by size. Okay, and so here we see it's basically an average of we can say the current level. Okay, and then in the last case we just need to return result, sorry the spelling is wrong, return result. Okay, so this is the approach. Let me see it's running or not. There's a mistake, sorry, we just need to write the push. Okay, now we see what's happened. Okay, so each test cases are accepted, and now we submit the code. Yes, this code is submitted in the big O n time complexity, and this is the code in front of you. I hope you understand the code, and we meet in the next video. Bye.